Welcome everybody, and thanks for joining this webinar. My name is Colin Hobson and I'm the CEO at OpenSpatial and be doing this webinar. Focus today is on using the National CAD standard when creating and validating GIS data, something we've been doing for quite a while at OpenSpatial. And you're more than welcome to go to openspatial.com and learn more about us as a company. The topics to look at is ACDC, which is the name of one of our products. Just to give you a little introduction to that, and then focus on the use of National CAD Standard, NCS, and various GIS standards, and then how we build our toolkits and enable data creation and build with the ACDC solution. We've got a portal solution and a desktop or on-premise, and those two work together. And we'll also look a little bit at rules and the rules editor and rules and checking and error marking, and about the solution and kind of how we roll that out with our topic. So what do we mean by ACDC? And the focus really is on automating the direct loading of CAD drawing data into GeoBIM models or digital twins. It's this little piece. It's the handover of information within the workflow. And that's what the focus is. And how do we do that? And in this context, we're talking about the National CAD Standard and specifically the ACDC solution. And if you zoom into that little piece and look at ACDC, it's one of our products. The acronym really stands for As Constructed Design Certification or As Constructed Drawing Certification. I can go either way on that. And that's our product. It's been going for about 12 years now, actually, as a desktop. And then the last 5 have been as online as well as desktop. Focus really being we want to get from CAD, and that's just a picture there, to GIS and get the data from one to the other. Instead of having a PDF handover, which we find more than 50% of data that gets into GIS is coming from PDF files, which in this day and age is really not acceptable and not advisable when we have CAD stuff that is survey accurate, fully attributed, sufficient for construction with all of the types and diameters and materials and elevations and everything built in. So what ACDC is a comprehensive solution. And it's a solution. There's multiple parts to it. I'm not going to go into every last part at this point. We're really just focusing mostly on the data and the CAD to GIS part of that, and particularly National CAD Standard. But ACDC is a solution for automating the workflow and the creation of and then validation and loading of data from submittals or as-built or as constructed documents, and to move that straight into GIS. And we can actually populate then anything, like asset management system or CMMS if you're old school. So the point being then, there's really 2 standards involved. The first one is the actual CAD standard that involves the first part of this workflow, and that is the creation of the data. And within ACDC, we very much are focused on streamlining the CAD process by changing as little as possible. That's one thing. And 2, streamlining the CAD process such that we want the data that's going to end up in GIS to be created at creation time. In other words, when the drawings are being drafted and created for construction purposes, we want to capture as many of those attributes by the person or organization creating those original documents rather than after the fact or recapturing. So that's also another philosophy. So you want to enable that to happen. In terms of 2 standards, at the end of the day, there is a GIS standard. If you are moving data into a GIS from any source, you have a standard. It's your GIS, what the features are, what the columns are, what the rules are, how the topologies are stored. Any and all of that is your GIS standard. So let's just move on then and discuss how do we go from there to there. So if I take that workflow of that handover, there's, starting with obviously design, build, and construction, or ASCON. There's this CAD part where there's the submittal and then taking that data. Now, traditionally, there'll be CAD and survey, there'll be a conversion, which is either a manual recapture or taking the CAD drawing and using any kind of tool inside of your GIS or inside of AutoCAD and working that by the asset owner or the people that are trying to get the data out of those particular plans. So typically be engineering, construction company doing the build out and have the data, and they'll hand over to an organization. Or if you have in-house designers, essentially it's the same workflow, it's just that they're also in-house, but you've got to then capture that information. If those CAD drawings are not consistent, then this convert and ETL process becomes a serious pain because you've got to figure out, well, what did they mean? And then also there's inconsistencies in those drawings. Did they add every attribute that you wanted? Is it in the form that you want? Can you take that digitally and push it straight through into your GIS? So this is what we're trying to solve This would be the traditional sort of stretched out workflow. And in modern times, we add digital twin into the mix as well, or a 3D design that starts in the CAD world and goes all the way through. And in many of those workflows at the construction stage, those 3D designs often get flattened down to 2D plans. In which case, do you take the 3D design or do you take the constructed document? Depends on workflow. So there's a thing there, and I'm not going to go into too much detail on that, but be aware that it's not as simple as this stretch out imagines. But the ACDC product really looks at a solution that goes end to end across all of that, including support for Civil 3D, and then pushing that straight into your GIS, whatever it is, any kind of GIS, if it's Esri or open source or OpenSpatial's Muntz's product, and then also including the support for the 3D as well, and going into digital twins. So why would we take this trouble? And in fact, I'd say that the GIS industry is late to the party. If you look at the AEC industry and coining the word GeoBIM models, we've been doing GeoBIM models for years. It's essentially a digital model of the real world in various forms, and there's a whole discussion around that. But the question is, how can the AEC industry hand over a building with all of the data and the model, whereas in GIS, we take a set of PDF plans is still the most common form of a handover of data, and that is really not the right form for that. So why use ACDC? Well, because it enables a full digital workflow. It speeds up the process. I mean, literally go from hours, days, or even longer to minutes to check a plan. And that changes things because now you can check at initial design phase, you can check at submittal phase, and then convert that straight through. The other part is we validate the data. Literally, it's about data. You want to check that you have all the depths, diameters, materials, elevations, etc. on every last piece that you want, that things are snapped, that they're closed, that they are not isolated. All of that you can do within the validation phase before you even accept the document. And that's really, really important. So that speeds things up. This sort of solution, it just saves years of work and reduces those backlogs, but it also really, really improves data quality, because now what you're getting out of those plans is there. Does it mean it's foolproof? No, because the actual submitted final as constructed document may not be exactly what they put in there, and so you still have to watch that, and you still need people. But the cost savings is significant, and so instead of recapturing manually every time, it's not a technology problem. We have the technology. It's more about a workflow and an organizational problem. So going back then to data standards. National CAD standard. So in North America, we have the National CAD standard, version 6 is the current one. It is a long-standing, basically, committee that built out the National CAD standard. And the goal there is to classify building design. The word really building design already tells you that it has a strong focus on building, which is fine, but doesn't necessarily include everything that somebody would want for typical infrastructure assets, particularly outside the building. But the point being to have a consistent and streamlined communication among owners and design and construction project teams. So it is focused very much on what we're talking about, but it's on the data creation side and very much a document focus and handover. And we need to add more than that. And so the National CAD standard, if you look at the benefits that they list, consistent organization of data, clarity of communication, streamlined electronic data management, enhanced potential for automated document storage and retrieval, etc., and streamlined construction document checking process. And that is absolutely the case. And that is that if you want to use the actual CAD drawing, you need it to be in standard form to be able to ease what you do with it and how you go about that, because there's so many wonderful different ways that CAD folks can draw their drawings, structure their drawings, and submit documents. So if we look at the National CAD standard, it's very good at providing a naming convention structure. It's got a great list of acronyms. There's, a number of 100 blocks provided. It forms a comprehensive guideline, and I would say it's a guideline as opposed to a standard, and they claim that in large part. So, there's a structure for the discipline, the majors, minors, and second minors, and you can go into all of that, and they've got good examples. The other part that it does really nicely is also give a lot of guidelines for the actual package of documents and how you deal with things like XREFs and sheet sizes and scales and borders and title blocks and all of these, and sheet numbering. Any organization should at minimum have this in place, whether they're using the National CAD standard or not, or whether they have their own versions of these, it doesn't matter. But your organization, if you're not giving guidelines as to what you're prepared to accept, then you already have a challenge consuming that information. We take that a little further in as much as we're interested in getting into GIS. And so that's where we get a little challenge on the National CAD standard. So the naming convention structure for GIS is a little different because we focused mostly on different geometric types, and we try and split those into features. And now we're going not just layers and layer names, we're actually going much further. So there's that. The other part is the National CAD standard has very limited examples and coverage outside the building. So there's a number of 100 blocks for things in the building. There's probably less than 40 for infrastructure stuff. And so you're kind of left on your own. There's a lot there. And the other part is when we've taken the National CAD standard, we actually typically also add or use a third minor. And there we put an annotation, point, line, or area to give you the geometric. And if it's a point feature, we often use that the type of what it is, and I'll show you that in a minute. So we kind of extend it out often to add that and use the National CAD standard in the GIS context. And I'll show you how we do that. So here's some examples. So say you're looking at water, you'd look at the GIS and you'd say, okay, we have a feature class for a backflow device, or the polygons for reservoirs or dams, or point features for hydrants. And so people will often have your GIS, which is really driven by database normalization. So something like a hydrant versus a clean out. A hydrant has a whole lot of different attributes, so we would split that out typically as a different feature because the database columns are going to be different required for that particular feature. So this is just an example of what we've done, and you'll see with the National CAD standard and GIS data models. So we split them into geometric types. We look at the CAD layer name very much driven by the National CAD standard formatting, but now you'll see it's a point, and the points then can be themed, and we'll often just add in the block name in there and follow a really whole lot of great acronyms and consistencies provided within the National CAD standard. But just to clarify on the CAD thing, we'll typically put that in. We'll also use both for the discipline. So this will be civil utilities, the CEU. Often people leave it out and then you don't know, is it just civil? So I recommend we actually use both of those. Here's stormwater, for example. So you'll see it's split by the feature type, and then within a feature type, if there's a column that differentiates one thing from another, we typically theme those. So that's what these light grays are. So these are excerpts from how we've deployed the National CAD standard, and I'll get into that, and against the GIS data models. So we can look at that. If we look at ACDC itself, it's a solution that started out as a desktop, so this bottom row, and the desktop is essentially a heavy application on AutoCAD that could use FDO to connect to GIS, any kind of GIS, which gives you the feature types, but can also then look in the drawing that you're active in at all the layers and blocks and configure then in this application, configure the templates, if you will. And so the first part of this tool was just to create the tool sets and things that you need to give to the CAD person so that they match the GIS. And so we use attributed blocks a lot. And that was at the start, say 10 years ago, and we've now built that out to also support civil 3D objects. But in terms of the configuration here, the ACDC desktop still serves as two things. One, for configuring your setup, and two, for actually processing and validating drawings. So if you're in-house, you can just take a drawing and use that template and validate it. If it's valid, you can push it straight into GIS, and ACDC desktop will do all of that. But in the desktop, at the same time, you are configuring what we call a configuration set and documents for what we call the toolkit. And those can now get pushed into the cloud. We've been in the cloud for about 5 years now in Microsoft Azure. And on that, there then is an entire portal website where you can go and log in, and we publish your configuration set and your toolkits into the portal. And then anybody with a login for that project, so the portal also gives an organization then the ability to have its own portal to do that full electronic submittal for typically contract or engineering companies or external folks, but a lot of times it's used internally too, where somebody can download the toolkit, draw the drawing with the standards, with the CAD standard, with the templates, and then submit that and get it validated before it's even set up for acceptance or submittal to the organization. So now it's a full-blown self-serve, digital, in the cloud tool set that you can use. And if we build that out essentially in two ways, if we look at these sort of lanes, so there's datas and standards, and we'll go and drill into that in just a minute. But the asset owners determine what documents are you prepared to accept for plans coming in, and where do you want to put that data and how do you want to process it. So as an asset owner, you would be in control of, this is what we accept for construction plans, etc. If you're a draft person, On the drafting side, you're controlling what layers are used, how they're drawn, how the documents are structured, model space, layouts, any of that stuff is all in here, and how you package that to get it submitted. So it's really driven by the asset owners to say this is what we want. And so if there's a lot of detail, and I'm going to whip through this, but we can go into later. But inside of each of these groups, there's this. And so when we go with the ACDC solution, we drive it from the GIS perspective, because that is one of the final recipients of the data. And so you can look then at your GIS, you can look at whatever specific standards you may have. You may have a CAD standard, you'll have internal processes, guidelines. You may have a library of record drawings, which are the actual drawings, and those may be DWGs, or they may be just PDFs, or they may be paper even, but you have all of that. And so we look at this, particularly driven by the GIS, to define what features, what attributes, what are the domain values, what sort of rules. Is it a segmented network? If you've got water, sewer, or storm, you want the start and end nodes and things like that. How does the topology stored? And so we build that out in ACDC in the desktop to get essentially a CAD toolkit, a validation set, and associated project documents. And at that point, you can go set that up in the portal and publish it out. You can also invite people to those projects, whether those are internal or external. So if we go then to the top line, there's a whole lot in there. The top line is really at the other end. This is you consumers. So as an asset owner, you would have the portal that would be in the middle here. You set that up. You invite people. They actually go download what they want, what they need, and then we make that completely self-serve. And then they can upload drawings into the portal if they fail to validate. So the validation's a big process. I'll have a few slides on that in a minute. And what we're doing there conceptually is making sure that the data in the CAD drawing, A, complies to the CAD standards, but B, and more importantly, includes and complies with all of the GIS data rules and attributes and data types and ranges and all sorts of stuff. And so that makes for a really good set of data. Once it passes, of course, you can push that back into your GIS directly with a standard conversion, which is fully digital. Push the button, makes your features and sets it in there. But we know now we've got good data, and you can output record plans. There's also a framework for notifying people, so you can send an email and say, hey, this project's ready to go, and notify people and accept plans, and it will automatically provide that feedback. So go back to the data. That was just an introduction on ACDC, but looking at the data itself. So I talked about NCS and CAD standards and layer naming. On the GIS side, everyone will have a GIS feature. Those are typically split by geometric primitives, text, points, lines, polygons. And within that, you would have a column or an attribute data type, and that would have its own description and data type. When we're doing CAD stuff, you want to be able to differentiate in the CAD drawing what attributes you actually need for any given feature type, and whether it has domain values that are applied. And so we actually typically have lists like this, and this is an extract from our off-the-shelf data model with the NCS that we're using. And so you can build that out. What we do then in that toolkit is the following. Within the ACDC desktop, you can build out a toolkit. And if we start at the end, you set a box where the project is, because we actually check the extents of that so that we can look at the coordinates to make sure that it's not some funky offset, local, surveyed, or whatever, because what we want is data that is projection accurate, in unit accurate, and in model space within the boundaries of where you want it. So you set the units, you set up your CAD template, you include all of the layers, and this would be an example of somebody using the National CAD standard. This is not our off-the-shelf model, but just another example of National CAD standard where they've slightly modified it. And you find this a lot. There's always modifications going on. They didn't put the C, they just put U. But in our off-the-shelf data model with the National CAD standard, we've built out all of the data sets and blocks. So we have over 300 blocks, more about 260 blocks and 300 odd layers that are infrastructure related for storm, sewer, water, natural gas, telecom, electrical, all the civil stuff, etc. And built that out. So here's just an example of some of those legends, but they're not just pretty blocks. They have all those attributes and whether they are displayed or not, and set that up. In addition to that, what we've done is we have the ACDC Configurator, the desktop, can also automatically create menus to go with those feature types. Because what we found is, and I can actually show that, if you look at AutoCAD, so here's ACDC on AutoCAD, this is actually Civil 3D, you'll see it adds a tab and there's stuff to connect things in database. If you go into Configurator, I'll show you those in a minute. But in here, If I look at this as an example of a template, and if I just type in for the layers, you can look at it. So this is an off-the-shelf data model with National CAD standard. You'll see there's 318 layers, and this is a challenge in and of itself, in as much as the asset owner is now asking whoever creates the drawing to use these layer names. They're probably slightly different, even though they're National CAD standard, than what they're used to. There's also 300 of them, so somebody has to go and learn 300 layers. And about 260 block names, which we've kept the block name very much the same as the layer name. That way it makes it way easier. However, you can't expect someone to remember that. So if they wanted to go in and wanted to say draw a line for a stormwater channel, for example, how do they know what that layer name is? So what we've done is we put that on the menus. So they can go to channel, and simple CAD menu will give you then the layer name because it's like a macro. So I can say, okay, I'm going to draw a U-drain, and by putting it on the menu, it automatically knows what layer it is. So now we don't have to tell people, hey, learn 300 odd layer names. We can say, just use the menu, and then you can go draw it and all the colors will be set. So if you set it up as a template, so this is an example of our off-the-shelf setup. And then on that, we use attributed blocks. So if I go to that, you'll notice the line is just a line. And I could have been a CAD person and typed line or P line in the command line, set the layer to obviously be the active layer, the right particular layer if I knew it, and I could have drawn the line. Don't have to use the menus. But if you wanted to on that channel, you also need to add the attributes for that. Typically, CAD folks would be drawing that. If they're not doing it in Civil 3D, they're going to be doing it, adding those attributes as text next to the line, or a attributed block or a leader line. If you're using attributed block, we actually also put that straight on the menu. And on the menu, we can automatically, once again, set the layer to be automatically correct, but also the snap mode, because we want the attributed block in the middle of that line. And so we can snap it to midpoint and put the angle. And that's all, once again, standard CAD stuff. This is not standard CAD, and I'm going to come back to that in just a minute. So back to the PowerPoint. So just that was a little aside to run through the menus, and we provide those for water, sewer, storm, and telecom and electric. So that's the toolkit. The other thing about that is we're using attributed blocks. The neat part about ACDC is we very easily can create all of these attributes that go with that particular feature type. So this would be potable water, blow-off valve, because I happen to know that block name. But there's like, I don't know, 280 of them or whatever. The challenge here is you're asking the draftsperson to know what acronyms you're going to use in the GIS for these columns, and they don't know that, and they don't know what your domain values are. So this inserting a block is great. At least you get the attributes there, but this is free format text edit. So this is the standard AutoCAD insert command, and if you select a block, this is what you're going to, if it's attributed, this is what you'll get. We actually produce a thing called Attributor. It's a free plugin. It's on the Autodesk App Store. The neat part about Attributor is it provides the same data. You'll see this is the same block. What it's done is we've added asterisks for mandatory values because we know what we want in our GIS, and we've added support for drop downs. That means now people know what exactly it is you want, and you can easily go and put those in. There's a few other things like descriptions and just making it easier and keeping track of what your version of whatever data standard you're using. But the Attributor is huge because it also provides a small little text file that encapsulates the drop downs and the feature types associated with any given block, which you can give to the CAD person so they can work offline all the time without having to be connected or live, and they can subscribe then. Essentially, it's an encapsulation of your GIS standard in the CAD drawing and provides this, which is a huge benefit for getting consistent data and drawing it and enabling the person to do that. If they don't fill something in, it'll give them little warnings. They can override it. Once again, I'm not doing a full-blown product overview here. We're just focusing on how do we get the data in CAD in a form where we can validate it and then push that straight into GIS using the National CAD standard in this case. So let's walk through that. Here's somebody putting in a storm pipe. As I showed you, we draw in that line here and we put down that block. If I just do a simple CAD thing, if I do an add edit, this is CAD editing of a block. It says give me the block reference, and I go and click on that guy on a good day. And here's this non-useful dialogue where it doesn't show you that much. And so with Attributor, we can go in, and all Attribute is just an add-in. It gives two things. You can edit a block or you can insert a block. And if you have a config for that, now when I go to the block, if I select it, would be on a good day, and I hit enter, it now goes and looks at the config to get like the materials. So there's none of this misspelling and you know what it is. It also shows things like what a description would be as opposed to the code. So that would be the description, but in the GIS you might actually want a code. So there's the codes, and in fact, since we're a GIS company and we put that in, we can show both. So you can display what's in the code and what the description is. You can add help here so that it pops out what it is. It flags mandatory. So this is a huge benefit for folks using attributed blocks. If they're using Civil 3D, we use property sets. And on Civil 3D, you get prompted already for a bunch of attributes anyway. And so that's how you would build out, say, something like this. This is an example where these are all attributed blocks. The other thing is CAD folks often will draw the line like this, where you have a long line and you want the attributes. So you'll notice this one has attributes there, the PVC 12-inch. But when we want it in GIS, it's got to be segmented, say, between that valve and this fitting, and there'd be a short little piece of line, and you still want the attributes there, but the CAD person is not going to draw that. So we actually account for that in the ACDC solution. But once again, I'll come back to that as a full-blown thing. So when you draw it, you draw a line with an associated block, or you draw an attributed block. These would be our off-the-shelf ones, just showing you a point line and polygon. The blocks are standard blocks. They're just CAD with attributes, okay? So you can still go in and edit all of those. And that's, we don't want to change that. And there's even utilities that people use a lot to go and, incrementally number blocks and this and that. And so we don't change any of that. So if you draw this, here's an example of a polygon with a block in it, so that those attributes will be assigned to that polygon. We also use the idea of a common block, which is kind of like a title block, but it's in model space. You can put any attributes you like in there. This one just shows 2, year, and project number. But you could put in, name of company or anything, or the phase or whatever it is, any attribute there. But this data in this block with ACDC can get assigned to all of these assets. So when you do a digital conversion of this data and these assets, it's going to go into each of the different feature classes, points, lines, polygons, and specific types of points or whatever. And it's going to have all the attributes, and you're going to apply this essentially metadata for project number, etc., as an example, into each of these features. Let's talk a little bit about then the GIS side. With ACDC as a product from our Australia office, and Australia as a country, as a nation, have actually put a lot of emphasis on consistent use of data standards. So they actually have a bunch of different standards. ACDC supports all of these. You can find out more, by the way, at asconstructed.com. That's the website for our ACDC product, asconstructed.com. It's just a normal website, but also has a portal link in it. But anyways, there's different standards that are there, and I mentioned those just to give you an idea that ACDC can support all of these. ASPEC's a fairly one that we've got a lot of customers on, and there's various other ones. ACDC supports any number of different standards. When we moved it to the US, we found that people were not just happy with, hey, it's a tool set that you can go and build your own standard on. So we did produce the off-the-shelf standard. So it's national CAD standard based, took a fair amount of time. And we took our Munsis product, because that's a database-driven GIS we've been working on about 20 years, and we have all of those disciplines already in there, and we've built those out over 3 different geographies in a 20-year period. So we took that, extended it out a little bit, and created what we've called a universal data model. And it's just a start point. It's just so that you actually have something that's functional, and so I can have you working by it tomorrow, basically. But it's a combination then of the CAD, the National CAD Standard-based guidelines, extended out to account for infrastructure. So water, sewer, storm, telecom, electrical, natural gas, air fuel even, because we have airport customers, etc. And that's got then all of those in the database side. So if we look at it, ACDC, if we look at the portal itself, the portal is essentially this top workflow that extends out a whole lot of functionality. You can do multiple format. You can actually take a set of shape files or even map info files. They do need to be specific file types with the same columns that are going to be in your GIS, but we can run the same validation on those that we run on CAD drawings, things like snapping, breaking, isolated, range values, closed polygons, all of that stuff will be run on those as well as CAD drawings. You can add additional documents in the portal. And their portal has a whole workflow thing where the person submits, it either passes or fails a drawing. They can keep submitting until it passes, and we know that it's done all of the checks that were configured. And then you can flag that as certified for that particular standard, which then sets a whole notification via emails to the review teams, to different departments, etc., who can then accept or reject. In the portal alone, we output a DWG file, the validated version that has object data on every piece of asset, and the object data is aligned then in the GIS side with the conversion. But you can actually just use the portal only. If you use the off-the-shelf data model, you'll get a set of consistently structured CAD drawings with object data and or shape files. Lowest common denominator set of shape files can be produced. So it just means you don't have to have the in-house database and conversion. You could be getting consistent data coming in. And what's happening in our Australian office, where we've been running this for 12 years now, there's a lot of engineering companies that just use the portal because it's a standard way of getting everybody across their organization to use a standard approach. And that helped a lot too. If you look then at the on-premise or the desktop, there's a couple of aspects. First one is the desktop itself provides then a template file, and people can just within their CAD environment go in and do a validation, make the corrections, do a validation, make the correction. It also then creates a valid output of a DWG with object data, which can then be converted, run the validation. We look at the rules straight online here and can be pushed all the way through. So whatever your database is, whatever your GIS is or your asset management, we'll push the data into that as needed. And you define that. If you sit in the desktop, as you set things up, actually I'll go and show you that. So in ACDC Desktop, there's to go from this CAD to this GIS, there's these two standards. And in the configurator, we really combine those. So the configurator looks like this, simple UI driven by attributed blocks. So those would be essentially akin to your feature types. And in any given block, so here's a whole lot of them. Let's drill down into it. There's the object itself, and it has attributes. So within the object, so if I go to one of them, so this one is a block, and that can be put onto a line or a lightweight polyline. It's a block of a given layer, given name, and because it's a linear feature, it has an associated block for that particular line. So any line or polyline on this layer with this block on, it's going to turn into a valid feature that's going to end up in your GIS. And so the output table, you can set the object data table names, you can set the FDO layer for output purposes. If you're in Muncis, you can say I'm using Muncis, and I'll set the Muncis feature type as the output layer. You can do, for the CMMS, you can enable external output as well. You also define where's the position of the block. So if you look then, I just clicked on the tab here, attributes. So you can go then into the attributes. So this is where anything in the common block, there's only two here, there could be more, but any attribute is here. And this is how we know what we want to put into those attributed blocks and where those are going to go and what rules to apply, like the data type, the width of those, the range, the minimum, the maximum, the destination column, and is there a lookup, etc., on that to be applied for those domain values. That's what I mean by lookup, by the way. Let's go a little further. Inside of the configurator, there are settings and there's spatial integrity. You can do graphics only. So if you just want just line work, often something like an easement's just on a layer for that type of easement. Sometimes it has attributes, but there's also spatial integrity, and inside of that, there's extended checks that we can do. So if we go back to that one, there's linear branching. So you can say that a property connection or service connection, those we define what the main is, what the type is, and that can determine whether you're checking for directionality of flow upstream or downstream, whether it's pressure or gravity system. There's also snapping, nearest and end, and point and break. So if I had a rule that said nearest point and break, you could go and put valve along a water line, for example, and then when we run validation, we'll on that valve, we know that that valve can snap to nearest point on a given line on a given layer, and it will then break that line, and you get a segmented model out of that. And so we check all of that stuff. There's also compound validations, things like or next level validations, single characters, substrings, and multi-values, things that need to start with or end with, or uppercase, lowercase. Also, this one is really cool. If the pipe material is a given type, then the diameter can only be in a certain range, that sort of thing. These would be in millimeters, I guess. But you can set up those sorts of multi-value checks. You know, if something is this size, then it can only be of this type, it can only be this size or these values. So those are very useful. We also do compound validation rules. So we've got is inside, link limit, and node limit. So is inside, so sometimes, says a simple one. Playground equipment must be contained within a park. Okay, you can't just put it any old way. Some of the roadways, often it's areas are split into polygons, and the center lines must be within a given polygon. Or you can have link limits, things like if I have a reducer, it can only have 2 pipes. For a manhole, it must be greater than 1, so you can't have this thing isolated. It's got to at least have 1 pipe on it, etc. The node limit, check how many nodes can connect to a pipe. So for a valve, you can set whether a valve can have any number of pipes on it. Mostly that would be a maximum of 2, depending on if it's a, compound complex valve. There's spatial checks, things like related attributes. If you have a pipe of this diameter, the fitting needs to be the same diameter. So those are rules you can apply. Rules can be solid rules, so it's a fail or a pass. All rules can be warnings, which kind of helps you on the guideline side of that house. And so we check all of that. So you can look at an attribute link check. So if a drainage pipe endpoint is connected to a second drainage pipe, so basically you'd have, say, 2 drainage pipes on the same manhole or drop inlet, the downstream invert of the pipe, the first pipe must be greater than or equal to the upstream invert, depending on how you go. Let me see. Downstream invert should be lower than the upstream, I would say. And you can set all of those and check it. So we're actually looking then between features what the relationship is on that. You can also do distance checks, and this can be between different features. US example that we would typically apply would be you can't have a sewer clean out within 6 feet of a water meter, okay? Or electric transformer near a hydrant, or a water connection point or valve close to a transformer, or any of that sort of stuff. In Australia, there's one of the rules for roadways, you can't have a driveway within, in their case, 7 meters of a roundabout, for example. So that's just an object distance. So you can go into ACDC desktop and go and check this sort of configuration, set that up. Looking at the validations, this is actually in the portal. When you run a drawing, you can get an output with error markers. We actually, if it fails, we'll actually show you. If your output is the GIS data, you can actually get that in GIS as well. It gives you a list. I don't like the list because it actually knows where the exact coordinate is of that issue, so it's easier to see it and mark it on the map. But the list is useful because it's a punch list. You can see what the results are, how much pass or fails there were, and you can look at that. But looking at the data itself, either in GIS, so here we're showing some output in QGIS, you'll see that this particular thing says missing a mandatory value for the origin. You can look at geometric errors, attribute errors. So this one has the street name missing on this particular pit. It actually shows you where that is, and you can see the error. If you look at it in CAD, we actually put a CAD circle there. We include object data on the circle itself. So it'll say isolated configured block found. So that basically means you've got a block there, and you can then zoom your way through these and go fix them and check. So you'll see like associated block is not contained within configured object. So basically the block's not inside of a polygon in this case, and you get all manner of errors. And so typically we provide a list of, the common errors and how you fix them, but we'll put geometric errors in red, and we'll have different colors, yellow and cyan, for spatial and attribute rules. So ACDC, pretty mature solution. 12 years, Portal 5 years. In those 5 years now, well, actually it's really first 2 years we're kind of getting going, but it's been moving along. Done over 10,000 validations over for more than 2,000 projects. And you can see it picking up pretty rapidly these days. And we're moving into the US, new product really for the US market in the last couple of years. And we have a full-blown off-the-shelf data model. So what we can do now is really take this workflow for regular CAD and Civil 3D, which is interesting because Civil 3D is great. You can model a lot of different things, but it doesn't cover everything. So if you're trying to draw a gas network, you got a problem. If you're trying to do a lot of the work, you'll find you get what I call a hybrid CAD drawing. It's got some CAD and some Civil 3D. And even the Civil 3D models, often in construction phase, as I said, they're put down to 2D models, but then that's the 2D data for construction purposes. And that's then got all of the field changes, the as constructed part of it, marked on those, not necessarily all the way back to the Civil 3D document. So you got to figure out how those work. So if we look at this little cameo, we start with the CAD. You use those tools on the toolkit. We do a whole submittal process which includes then all of the validation, closed polygons, isolated nodes, snapping and breaking to create a full segmented model, all of the attributes and range values, domain values, that those match the GIS. And you can do that in the portal. You can do it on the desktop. Here's somebody's portal. You can see they've submitted 35 failed drawings or submissions and 15 passed. And that's kind of normal, 1 to 3. And notice the time. It's like just literally minutes to process a full-blown drawing and see the results. And so in the portal, you can get workflows and set that up, but literally go from that picture to this picture. If you do have a digital model, you can actually put that straight into your digital twin. This is an Australian example. Australia have a national digital twin as well, and some of their states have their own ones where they've literally got all of the 3D stuff. So this would be a new development, and that would be the ACDC processed line work there, and you can just see it from the drawing straight into that in a matter of minutes. But more importantly, in the GIS, you've got all of those attributes in there. And so just to show you then this drawing here, there's a common block. So this one's just set with only 2 values to apply as metadata, the project number and the year, to all of these assets here. This would be the water network, but in this thing we've got in model space, according to national CAD standards, using essentially these pull downs. So for water, you'd have something like, all of these, system valves, blow-offs, etc., all on your menu. And you could put those in here and draw this out and then run validation. When you've done validation, you've got all of that data from this project. So this is 3 phases. Well, this is phase 1, 2, and 3. And then there was another new development here that had the parcels. Run that through the portal, asconstructed.com, and get a final result. So let's just pop this over here and go to asconstructed.com. And so this is their website for asconstructed.com. It looks like a regular website. You can see things like training and videos, and you can go look at the videos there. Project is for essentially engineers. So this would be somebody who just wants to use the tools for just standardizing their CAD process. But the enterprise is where you probably want to go as an asset owner. And it just highlights this document and then runs through the process. There's info you can get there. You can look at the brochure there. More importantly, there is then also a login to the portal. And you can go and look at that and actually log in. So I'm logged in here. I'd have my own dashboard. It would have a project here, typically documents like the install, hands-on, common errors. Point being that when I log in here as a draft person, I can get all the documentation set up by you as the asset owner to go in and draw stuff, including the toolkits that I've been showing, etc. And then I can go in and submit a drawing against that. So here's this drawing, all phases of that drawing I just showed, and you can see it's got 800 odd entities in it, and it's been validated, and it went from 545, and the submission successfully passed there. Took just less than 5 minutes to actually run through a decent sized development there, and you can see the stats for it. I could then download that GIS data as a shapefile or as a drawing with object data. And if I take that shapefile and download it and pop that straight into something like QGIS, there's the parcels and easements over there. Here's that same water data. And if I go and look at this here, let's go to water pipeline, you'll see that as I select that, it's got the attributes in it, the PVC, the diameters, and it's straight into GIS. So literally a matter of less than 10 minutes, I can take this entire CAD setup and push it all the way into GIS. Thanks very much, everybody, for attending. Thank you very much for your time.